Hi guys, this is Sam. Officially Salvatore Michel, but my nickname is Sam. And most likely, this is going to be my last video for a while. I'm running out of space. I'm running out of the 50 original allotment on Bright Eon. And this video is specifically for Bright Eon. And I can, my let me put it in a funny way. My imaginary friends on Bright Eon. Okay. I hope that someday they're not so imaginary, that they're real, and that I hope someday that we're not obsessed with what I call. I have this expression, fighting the power. The evil overlords. I don't know how else to say it, but yeah, I have this fantasy that someday we can laugh about, we can have a beer together and laugh about all this crap during Corona. But until then, we're all going to be suffering and complaining. I have a feeling if there ever is a day that we can have a beer and laugh at this stuff, God willing, it will happen someday. But in the meantime, while it's going on, I think most of us are suffering and most of us are complaining. And we have a right to complain. And we have a right to, quote unquote, fight the power. But, I mean, peacefully. Anyways, so God bless you guys. And God willing, someday we will be able to have that proverbial beer. And it's more than one, okay? more than one. And more than just a couple Guinnesses, okay? We're going to have a whole keg, at least a keg of Guinnesses, at least, okay? Once this is all over and we can laugh about it, we're going to have a freaking keg. And even if it has to be on me, man, even if it has to be on me, it's going to be a keg of Guinnesses and everything that everyone loves, okay? God willing. All right. So I pray for that day, man. All right. But in the meantime, this is going to be my last video for Bright Eon. And I also have a channel on YouTube that I'm going to co-publish it. But the thing is, I have no subscribers and no watchers on that. So forget it. Forget about the YouTube channel. This is for Bright Eon and my future friends on Bright Eon. And I do a lot of complaining. I do a lot of complaining. And I do a lot of bitching. But this is about science that I love. Okay, this video article is actually a combination of 3 of my most recently published articles on ResearchGate. That's the main venue where I publish, and it's what they call preprints, and it's mostly physics. Very mathematical physics, but please bear with me because it's the love of my life. Okay, it's the love of my life. There they are. Obviously it's a JPEG and 3 articles, and we're going to go through it 0 through 3. Okay. We're going to start with the JPEG because why, and you'll see in a minute why it's important. And you're going to like, what? Yeah. Okay, that's pretty self-explanatory, and I shouldn't have to explain the additions to my version of the standard model. Although there's some minor what do you call it? Not discrepancies, but minor details that I would like to discuss. And if you know anything about physics and the standard model, you're going to notice 2 additions to this. Okay. In the bottom is a vector boson addition. It's the X, and I did not discover that. That's a team. I think a team in Europe that discovered it. I think it's a team in Europe. I've already tried to write them about this, but they, no response, of course. Nobody responds, man. Even when it's in their favor. You know what? I think you know what I mean. No one freaking responds, man. No one cares. No one cares. If it didn't come from them, they don't care. The thing is, even when I add their particle in the standard model and try to respect them, the group that discovered the X, they don't care. No response. I mean, I'm like, okay, I get it, man. I get it. It didn't come from you, so why should you care? All right, anyways, yeah, they never responded. The group in Europe that discovered the X. And the group the American that discovered the elaston, you're talking to them. Yeah, and I'm not. Trust me, I'm not tooting my own horn. I'm not bragging. In fact, I'm ashamed. I'm ashamed that I came up with the. I'm ashamed I discovered the elaston. Yeah. Well, I'm ashamed that I can't get anybody else to care. I'm ashamed I'm ashamed that that I have zero ability to motivate other people to care. But anyways, I really think that even if Corona wasn't happening, still nobody would care. Because what? They didn't come up with it themselves. And I haven't figured out a way to inspire them to care. That's on me, man. That's on me. I don't blame anybody for that. Maybe someday you guys will see the standard model modified, or at least the X. I don't think you'll ever see it in our lifetimes. In our lifetimes, you're never going to see the elaston in the standard model the way I've drawn it here, or photoshopped it here. But you might see the X. You may see the X, but no credit to me. It's to the guys the discoverers in Europe. And it's Attila the Hun, man. Believe it or not, Attila the Hun. Yeah, it's my nickname for him. It's a scientist in Europe who's a Hungarian. My nickname for the discoverer of the what do you call it? The principal investigator for the team that discovered the X. All right. Anyways. So yeah. All right. Yeah, you're never going to see the elaston, but not in our lifetimes. But you may see the X. All right. So that covers that. Oh, and it's protophobic. The X is protophobic, so you probably should, if you could zoom in on that little section of that. I don't know if you can do that or not, but if you like take a picture, a screenshot, and then zoom in, there should be more data about the what we call it, positivity, because it's protophobic. If it's protophobic, that means it's positively charged, right? Or at least that incarnation of the X is protophobic. Proton-phobic, protophobic. So yeah, that's the final commentary about the X. All right. Anyways, yeah. All right. So that's my. Yeah. If you can put your finger over the elaston and kind of hide that, that's probably someday maybe within 50 years you'll see the X show up on the standard model. Maybe, God willing. God willing. This is, if it ever fucking pulls, excuse my French, but if it ever pulls up, there you go. Huh? There you go. What's the deal, man? All right. I have no idea if Bright Eon's going to let me have the resolution to be able to see this thing. I don't anticipate that I'm going to read everything for you guys. God willing, I'll put the links in for the articles that are available on ResearchGate. I'll put all three article links in the comments or whatever. So I don't anticipate that I'm going to read through all three articles for you guys, but I can sort of overview them. I think that makes a little bit more sense than reading through. If I read through, that's going to be really boring for everybody. So, But I can sort of skim and give the highlights of the articles. I think that's justifiable and that's appropriate. If I can actually freaking read it, it's a small print on my screen. I'm using a smartphone, so it's really small for me. But this article starts out, and it's basically about the notion of conservation in science. There's conservation of charge, conservation of, well, at least let me read the first part. Conservation is a core notion in physics and chemistry. Whether a chemical reaction is exothermic or endothermic, heat energy is conserved. Now we can think of that as molecular binding energy. In physics, there is charge, spin, and parity conservation as a form of holistic or integrated kind of conservation. But for clarity, we'll focus on charge conservation. So it's not really an abstract, many venues like Archive, which is a Cornell thing that requires like an abstract. I think generally speaking, that's like conventional standard preprint stuff. And the only reason I'm able to do it on ResearchGate is to publish preprints is because I don't know. I mean, can I? Huh? if you there's nobody here except me, right? And a fan. So if you hear some wind on the microphone, the device microphone, please forgive me from the fan. And there's nobody in the room except me. This is the living room of my house in the Philippines. What's my point? Oh, sometimes I ask for this other person's opinion. Like, you hear me like, and I'm like, huh? What? Oh, it's okay. It's okay to talk about this? Well, that's my invisible friend, okay? And it creeps my wife out when I talk like that. My invisible friend. Other people might refer to that entity, that person, as God. I would, but my nickname for her is the PG. So I don't want to I don't want to waste a lot of people's time who, like especially atheists. Screw it, man. I mean, if you're an atheist listening to this, what I want to do is when Corona's over, if it ever is over, have a beer with you guys, all the atheists listening to this, and have a beer. And just laugh at the religions on the planet, the ridiculousness of the religions on the planet. Just laugh, because I'm with you on that, man. I think most religions on this planet are so freaking smug that we should just laugh at them. That's the only solution, is to laugh at their smugness. I hate smugness in any shape, any form, especially religious smugness. So. You want to have a beer together and laugh at the smugness of religions, contemporary religions on this planet, or even dead religions? Fuck, man. I'll freaking pay for the beer. That's how much I hate smugness, especially religious smugness. Anyways, so maybe someday, all the atheists listening to this and all my future buddies on Bright Eon, if there is a future for humanity. It looks pretty bad in the States right now, man. It looks pretty bad. It looks pretty bad in the States, man. But, I don't know. You never know. All right, so let's say, so back to, so if I say, huh, it's my fantasy of a God that actually freaking cares, okay? Let's put it like that. So back to physics. This is probably the most important article that I've ever written in my entire life. I think it's safe to say it's the most important article that I've ever, in the 40 years that I've been thinking about and caring about physics and understanding what's really going on in the quantum realm, what we call the quantum realm. I haven't been writing articles that long, but I have been. I have been caring and trying to understand for about at least 40 years. Um, this is the most important article I've ever written in my life, and we're gonna go to the end. If I can freaking read it. Now we can understand why CC is just a cute way for me to say curvature conservation. CC is more fundamental than an energy conservation. I mean, that's quite a statement in itself. Okay. If you know anything about physics, if somebody tells you that curvature conservation is more fundamental than energy conservation, you're going to say, well, what exactly is curvature conservation? So I can instantly and immediately disagree with you. Because everyone knows in physics, if you know anything about physics, energy conservation is probably the most basic form, the most basic core fundamental form of conservation is conservation of energy. And if I told you, even as a student of physics, if I told you that I discovered a form of conservation that's even more fundamental than energy, you're like, you have to prove it to me, man. Because all I know is that energy conservation, like E equals mc squared, energy conservation is the most fundamental form of conservation in physics. You got to prove it to me. And I do over 3 articles I do. But no, this is just the beginning, the introduction to the whole framework is my article on conservation, which is, again, probably the most important article that I've ever written in my life. It ends with a statement of a question, really. This article ends with a question. And what's the question about? The nature of dark matter. So I say the framework cannot explain the nature of dark matter, but that is left for curious readers to investigate. So, some of the most important article that I've ever written in my life, and it was published earlier this month, July 19th. I'm sorry, that's tomorrow, but that's tomorrow, but I wrote it like last week, intending to publish it tomorrow, but I actually published it yesterday, on the 17th. All right, so anyways, but it's the most important article I've ever written in my life, okay? This article called Conservation. Because implicit in the article is there's a lot of stuff in here, in this article, that if you really know anything about physics, there's so much in this article that's sort of hidden, underneath the surface, that's sort of hidden and implied, that it's going to change. If it's true, it's going to change everything. If it's true, it's going to change everything in physics and science. If it's true, it's going to change everything. All right, so that's conservation. This is the kind of bridging article between the 3. That was also published tomorrow. Also tomorrow, yesterday. Yeah, so this is another one, because I didn't anticipate to have internet until tomorrow. But I did something for my wife yesterday so that she could have internet. And since I did her stuff, I did this stuff yesterday when I really intended to do everything tomorrow. All right, anyways, so this article, what do you call it, the layout, it's not as straightforward as the last one. It's not as straightforward as conservation. This is kind of like haphazard. Its structure is haphazard. There's no abstract. There's no introduction. It's just kind of haphazard, and because that's the way I wrote it, and that's the way I'm presenting it. I'm presenting it as honestly as I can, as haphazard as it formed. And really it started out as an action plan for myself to try to figure out how I can prove to science that this stuff is valid. It's not just me jerking off over porn. I mean, I use that expression when we're just kind of spouting and not opinions and not really based in any kind of evidentiary way. When we're just spouting opinions, we're just kind of jerking off over porn. But this article is not really about that. It's me trying to figure out an action plan how I can show the rest of science that what I'm speaking of is actually true and accurate. Anyways, so I'm trying to come up in this article or essay, whatever you want to call it. In this article, I'm trying to come up with an action plan for myself. Okay? And so page one is essentially me trying to come up with an action plan of how to present this stuff for the rest of science that is actually really real stuff that I'm talking about, not just me jerking off over porn. All right, so at the end of page one, I'm coming up with an action plan. The action plan is actually coalescing in my consciousness. And in in black and white, there's the article in front of you. But at the middle of page two, I kind of abandoned the action plan, kind of, because the action plan is, all I end up determining, once I formulate an action plan for myself, I realize that all it's going to do is kind of somewhat justify elaston cosmology, somewhat justify. If I actually find, indicators like a need for it. In other words, I was trying to study, I ended up, as part of the action plan, I wanted to study for myself, this thing called metastable hydrogen, which is something fairly recently discovered in science. It's a state of hydrogen, anyways. Anyways, metastable hydrogen, and then also metastable helium. And my action plan was to study both of those things, and try to determine if what's 5b? Well, 5b would imply an advantage of elaston cosmology explaining differences between what's ASMSs. I have to atomic scale metastable states versus nuclear scale metastable states. So I came up with two examples of metastable states for very light nuclei. And that was what? Oh, it's right there. Okay. Metastable scandium 44 and metastable chromium 51, which evidently is the two lightest isotopes that exhibit metastability at the nuclear level. And as you can see, their lifespan, the half-life for each of those isotopes. One is for the metastable scandium 44, it's 4 hours, and for the metastable chromium 51, it's 665 hours is the half-life for that. And my explanation for that has nothing to do with elaston cosmology. So it might, as my scientific understanding of those two metastable isotopes has nothing to do with elaston cosmology, and everything to do just with the available energy of those metastable states, nuclear states. So Hi, Mom. Thank you, Mom. She brought dinner. Thank you, Mom. So back to the article. So that it's haphazard because it was written haphazardly. It's kind of incoherent because I'm trying to create an action plan for myself to present to the rest of science, sort of like a kind of like intuitive justification for elaston cosmology, or how I can see the need for elaston cosmology, like as a motivation. I mean, why is it necessary as a motivation? And why is elaston cosmology necessary? Why? And I would present that like to a conference, like what do you call it, multidisciplinary conference. What do you call it? Conference of scientists of all different disciplines, like nuclear chemistry and whatnot. So why is elaston cosmology? Why should we even consider it? To give them some more motivations. But at the end of the article, I'm like, I'm not really sure if this is, if that's a very good approach to sort of justifying why I would ask other scientists to consider elaston cosmology as a framework. So let me try to, So at the end of the article, this kind of bridging article between the two, where I'm trying to figure out a way to sort of, what do you call it, inspire other scientists to even pay positive attention to the framework. And you're like, God, dude, you're all over the place. No wonder scientists don't listen to you, because you're just like totally incoherent. And I agree with you. I mean, it is this article is incoherent, and I'm just trying to be accurate about the article, and it was really, I wrote it for myself as an action plan to try to present why I'm trying to get, why other scientists should listen to me about elaston cosmology, which is a framework, a physics framework, but it's got 3 parts to it. And anyways, so in the process of writing this article, I was able to sort of not reformulate, but simplify the framework to absolute minimum number of assumptions. If elaston cosmology can be expressed or written down in a very few statements, like logically dependent statements, and that's what I ended up doing. I mean, in the process of trying to what do you call it, develop an action plan for myself to explain to other scientists why they should listen to me about elaston cosmology, I ended up sort of not reformulating, but rewriting the basic assumptions, and not just that, but the motivations for each part. So that way it became really clear to me, so I could tell other people what are the motivations for the entire framework. Okay, so and the sort of logical dependencies within the framework. So in the process of writing this article, I realized that so there's three basic parts to elaston cosmology. There's elaston cosmology itself. There's this thing called antimatter physics, and then there's which I realized is really tied to elaston cosmology, much tighter than the other part, and this other part called TCT, temporal curvature theory, which is a kind of replacement for general relativity. It's a simplification of GR. So in the process of trying to come up with this freaking action plan, I I realized that, so I must chastise myself because of the blanket assumption of independent validity of the parts of the framework. Only TCT is somewhat independent of the other two branches. Antimatter physics and elaston cosmology are intimately and inextricably tied together. So I realized those two branches of this framework, the three-part framework, antimatter physics and elaston cosmology, they're both going to be true or they're both going to be false. They're that tied together. Okay, so that's why I said in that small paragraph, I said that they're both are Zor, neither, exclusive or. They're both true or they're both false. And because they're so tied together, I said, so it should be fairly easy to disprove them both. So, and what was the equation above? It's that equation where I used Enya to replace N bar. My keyboard won't, Gboard on this device won't let me do that. I mean, do an N bar, which is like an N with a bar over the top of it. I can't do N bar on the keyboard, but it will let me do Enya, which looks like a little bit visually like N bar. So I use L sub N bar to mean the mean lifetime of a free anti-neutron, which I predict according to the framework, because and I explain why I predict this. But science makes predictions, right? Good science makes predictions, and it's falsifiable. It's good science is falsifiable. Bad science is not, but good science is falsifiable, and this is falsifiable. So it's good science, and it's easily you could easily disprove it if you could generate a sufficient number of anti-neutrons. And be able to keep thermal, like very low energy, like thermal anti-neutrons. If you could generate thermal anti-neutrons and observe them and observe their mean lifetime, you could easily invalidate this framework. So it's testable. The framework is testable, and that's part of good science, man. That's good science. That's something that is easily disproven is good science. I didn't say it's easy to generate low energy or thermal anti-neutrons. I didn't say that's easy, but it's easily once that's done, the framework is easily disproved by simply observing their mean lifetime, and I predict it to be 1/16 the lifetime of free neutrons, which is about, I don't know, 50, It's whatever, 16 times 55 seconds, whatever that is. Okay, anyways. So that's one way to disprove it. The other way is to prove that the half-life of tritium is identically equal to the half-life of antitritium. But the thing, this might be difficult since the data from Brookhaven already indicates they're not equal. Okay, so in other words, I have some evidence already that the framework is potentially valid in the Brookhaven data. And all you got to do is look at the Brookhaven, and you're like, what are you talking about? There's some data. Jesus freaking Christ. Of course they're going to do this kind of crap right when I'm recording. I hate that shit, man. Life in the Philippines. All right, anyways. So, I should just pause the freaking recording until this shit is over. All right. So that's over. Thank God that's over. All right. So, yeah, I do want to apologize for the incoherence of this section dealing with the second article, but it's the article was haphazard. in construction, but it did have some, what do you call it, positive outcomes, okay? Definitely, or else I wouldn't be covering it. So the framework can be easily disproved if thermal antineutrons are generated, or if they examine the lifetimes of antitritium and compare it to tritium, the lifetime of tritium. So there's at least two ways to disprove this framework. At least the APEC part, the antimatter physics elaston cosmology part. But it's fairly straightforward to disprove the framework, and all they got to do is measure the lifetimes. The what do you call it, the mean lifetime of thermal neutrons, antineutrons, and compare it to neutrons. That's one way to do it, and the other way is to examine the lifetimes, the mean life or the half-lives, which is it's just another way to express mean lifetime. Is to talk about half-life, but it's another way to talk about pretty much the same thing. But is to compare the lifetime of antitritium to the lifetime of tritium. But there's already indications from actual scientific evidence from Brookhaven National Lab that looks otherwise. And if you're curious about that, you can, I think it's the Brookhaven Star DTAC. Anyways, it's a particular experiment at Brookhaven that produced significant amounts of antimatter, because they were just trying to see about, what do you call it, they're trying to understand baryon asymmetry. There's a lot of things they're trying to understand with that experiment, but one of the things they were not anticipating and didn't discuss at all, but the evidence is there in the data, that what I call the antitritium deficit at Brookhaven. You're not going to find it. You're not going to find that data under that type of search. Like, you can't just Google antitritium deficit at Brookhaven. It's not going to show you anything. What you want, the experiment was like star DTAC, or I don't know. Anyways, where they're looking at what do you call it, populations of antimatter, and essentially it's equivalent when it's what do you call it, like when they're producing matter and antimatter together in these intense collisions, whether it's LHC or any other facility. Usually it's 1 for 1. Every time they produce an antinucleus, there's a nucleus produced, matter nucleus. So it's, matter is, when you create matter out of pure energy, and usually it's accompanied by an equal amount of antimatter of that nucleus. So whether it's protons and antiprotons, we call this pair production. Protons and antiprotons, or deuterons and antideutrons, or tritium and antitritium. If you're creating nuclei from pure energy, and like what we call pair production, and so whole antimatter nuclei from energy, it's typically in equal amounts, because it's 1 for 1. That's just the way pair production works in nuclear physics. Whether it's beta particles, positrons and betas, that's a balanced pair production. So, and that's conservation and there's a lot of conservation in there. There's a lot of conservation in there, not just conservation of charge and energy. But anyways, so it's fairly easy to disprove the framework. So this article number 2 that we're covering is important, even though it's haphazard and whatnot. Even though it's haphazard and kind of chaotic, it still ends very well in that we have very good tests for the, what do you call it? The framework is easily disproved if you measure certain observables. Obviously with a certain amount of confidence, significance. All right, so, and then I come up with an expression about invalidating TCT also. But the only way that you're going to invalidate that is to prove that the only way to prove TCT isn't better than GR is to show acceleration gradient fields are not equivalent. That's more like a theoretical invalidation. So if you can mathematically prove that they're not equivalent, then yeah, TCT is crap compared to GR. But if you accept that they are equivalent, which it was designed that way, I designed TCT to be equivalent to GR, then it's a little hard to prove that something that isn't what it was designed to be. You can ignore it and pretend, oh, he didn't really do that, or he's just an idiot. He's talking out of his a-hole. He doesn't know what he's talking about, and just ignore and dismiss me and make fun of me. But you can't do it based on logic and rationality. So that's why I come up with that statement. I say I'm all in because I got a friend who's he's gambling. He's a poker player and everything, and so he's always going to the casino, playing poker and stuff, and playing poker online. So I use that expression. So I'm all in. I'm all in, man, on this stuff. Once I figure out, what are the potential objections to the theory, and what are the ways to disprove it, then I realize, screw it, man. I'm all in. I'm all in, man, on this stuff. I'm all in. So in the process of writing this paper, and then I'm adding stuff, sort of addendums to this paper, I come up with a section of motivations and core assumptions. So the the ellipsis on top and the ellipsis below, as you can see, is this addendum on motivations, primary motivations for each section, each part of the 3 parts, motivations and primary assumptions. So there was a lot of use for this article. Even though it's haphazard and chaotic, it doesn't matter because in the end, we come up with motivations. This is prime motivations, not just some bullshit casual motivation or trivial motivation. These are prime motivations and prime core assumptions for the framework. And if I got it down to a few motivations and a few assumptions, that's pretty darn good, man. That's pretty darn good. That means God has guided me on a pretty good path here. And I'm not wasting anybody's time, most especially not my own. Oh, and by the way, we end the article with a freaking test. Okay, a test, another test. So not only do we have the 2 previous tests that we mentioned, that will totally invalidate the framework if it's proven, if they detect like equal decay rates between the matter and antimatter counterparts. So we not only came up with 2 tests in this article, we came up with a third one. A third test. What more could you freaking ask for, man? What more? This is real science. This is not bullshit. This is not me talking out of my a-hole. This is real science. This is not easily dismissible. Not when I give you 3 freaking tests. Okay, 3 tests of the framework. And the only reason that people might not do it is because they don't want to admit the truth that it's fucking, excuse me, my French, it's fucking valid. Okay, that's the only reason that they might avoid doing the tests, because they're afraid that it's actually fucking valid. So yeah, Article 2 ends up with a third test of the framework. And it's feasible. It's definitely feasible. And basically you're putting an atomic clock right next to the anti-proton beam at the LHC or other facility where you get a nice solid, a nice quote-unquote solid beam of anti-protons. And you can put an atomic clock right as close as you can to that beam and measure the passage of time right next to the beam. That's a way to test the framework. Because why? In the framework, it predicts that a sufficient collection of antimatter is going to actually speed up time. Ooh. And I'm just going to give you guys the link for this article because, and I'm not going to cover it because this is the, if you want theoretical proof of anything, this is it right here. This article was written back the 5th, or published on a couple weeks ago, a couple days ago, I should say. This month. And this is the, what do you call it? The core theoretical article. And it's like the legal argument. If I have to take it, if somebody took me to court about the legality of this stuff, this would be the article I would bring to court. Other than conservation, which is definitely part of the theoretical argument, but that's like the core theoretical argument is the article on conservation. But this is the meat, what I call the meat and bones, man. This is the meat and bones. I was kind of joking in other unpublished segments that I said, well, this article is the meat and bones. The middle one that we just went over is it's the flesh and blood, and the skin is the conservation article. But the reason I started with conservation is because it's the core, what do you call it? It's the most important article I've ever written in my life. That's why. And the connecting one, yeah, it's what do you call it? It's kind of haphazard, but it ends in 3 tests. 3 conclusive tests. And if it didn't have those tests, it wouldn't be part of science. So yeah, it's definitely part of science. Whether or not other people will, other scientists will accept it as, what do you call it, as worthy of testing, that's something else. That's future history to decide. But if they're doing it for emotional or egotistical reasons, or because they just want to have a stranglehold over funding and public attention, that's their infantile attitude, and I don't care. I've already published articles about that as well. So that's it right there. In a nutshell, that's three critical articles. I'll put together the 3 links and so I can publish them with this I don't know, video article, whatever you want to call it. And guys, I can only guess about the initial audience for this. That maybe it's other Bright Eon creators listening to this. Maybe if there's any interest whatsoever in physics or science or whatever, especially with bullshit Corona going on. But we shouldn't give up on anything, especially the things that we love and we care about, like me and physics. Okay, I'm not going to give up on physics. It's my life, man. For 40 years, it's been my life. God willing, I'll have another 40 with it. God willing. Anyways, God bless you guys for listening, and God bless you guys for caring, if there is such a thing. And maybe someday we can have some beers together and laugh about everything, laugh about the smugness of religions, and laugh about the smugness of people in power. Anyways, God bless you guys.